Okay, A-Day students, this is your virtual day, one of your virtual days. I want to help you out with your test preview that you are looking at on the PDF. So I'm going to go over the A part of each question for you and leave the B for you to do and try on your own. Okay, so question 1a says the temperature in Vancouver was recorded over a period of 4 hours. The equation y equals negative 2x plus 43 describes the temperature, and you can finish reading that. And again, you can pause this if you ever need to for your convenience. But remember the y-intercept, the 43, is where everything started. The negative 2 is your rate of change, your slope. It tells you that the temperature is dropping. So this answer, we need one to say where 43 is when it was started, which is C, it looks like. It was 43 degrees when the temperature was first measured. That's where it began, and it's dropping 2 degrees per hour. Okay, so there's 1A. Let's look at 2A. It's giving you a little chart here and asking you to tell what the slope and the y-intercept are. The y-intercept, remember, is easy to spot. It's the one that starts with the 0. This is the point that's on the y-axis. So 0, 5 is the y-intercept, and to find the slope, you put it in slope formula. Write your 2 points down, put them in slope formula, and your slope is 1/4. So the slope is 1/4, y-intercept is 0, 5. Number 3A. Identify the function shown in this graph. Well, we look at the line itself, and it's going up and to the right, so we know the slope is positive. So it can't be A or C. It's either going to have to be B or D. So let's look at the y-intercept. The y-intercept is positive 4. So D is the only equation that shows a positive slope, and the slope is 1, and a positive y-intercept of 4. And we can check that the slope is 1. If you go up 1, over 1, or down 1, left 1, you still stay on that line. Okay, number 4. Car travels along the highway to Denver at a steady speed. When it begins, it is 300 miles from Denver. That is your y-intercept. That's where it's starting. This looks blurry to me. I hope it doesn't look blurry to y'all. When it begins, after 3 hours, it's 180 miles from Denver. So there's that point right there, 180. Which function describes the car's distance from Denver? They all show 300 here, but it wouldn't be a negative 300 miles, so it can't be A. So we need to find the slope. Either the slope is 40, negative 60, or negative 40. And you can see here I have it worked out for you. The slope is negative 40, so that's your equation right there, which is D. Number 5A. 2 sailboats are traveling along the same path away from a dock, beginning from 2 different locations at the same time. John's boat begins 30 miles from the dock and is 50 miles from the dock after 5 hours. The distance of Roberta's boat from the dock is represented by the function y is equal to 5x plus 25, where x represents the time and y represents the distance from the dock. So we have John's boat. He's 30 miles out. Remember, that's our y-intercept, so that's 0, 30. It says after 5 hours, he's 50 miles out. That's another point we can use to find the slope. Put those 2 points in slope formula, you find out the slope is 4. Then you can write your equation, y is equal to 4x plus 30, because 30 is your y-intercept. They give us the equation for Roberta's boat is 5x plus 25, so we have to find the one that describes this correctly. John's boat was further out, but Roberta's boat traveled faster. So John's boat was farther from the dock, and it traveled more quickly. A is not correct. D, John's boat was farther from the dock, but Roberta's boat traveled more quickly, so it would be D. Okay, and I'm going to end the video here, and I'll have one more video for 6 through 11 if you need to see that.